Hello, and welcome to the final FMSP Core Prerequisites video. These videos are designed to help you get ahead with independent study of the A2 Core, ready to develop the skills in A2 Further Pure modules. Make sure you are really confident with all of these ideas before continuing. It's a very good idea to do the consolidation work for the earlier videos before you watch this one. You'll need these things to hand, so pause the recording now and go and get everything together. And make sure you've set aside sufficient time to do the questions, as well as just watch the video. In this video, we'll be looking at a way of multiplying vectors. It's called the scalar or dot product. If you study vectors in Further Pure modules, you'll meet a different way of multiplying vectors, called the vector or cross product. We're going to start by looking at the angle between two vectors. There are two different ways of looking at this which would give you different answers, so it's important that we define this carefully. The angle between two vectors is defined as the angle that is formed when the vectors are placed either tail to tail, as in this example, or head to head, as in the second. You can see that it doesn't matter which of these two we do, we'll get the same value of theta. But if we put them head to tail, we'd get a different value of theta. So that's not what we do. We're going to start with an example and use the cosine rule to find the angle between two vectors. Then we're going to generalise and get ourselves a really useful result, which is called the dot product. So I've got my two vectors P and Q, and the first thing I need to do is find their modulus. So working in column vectors, because it's easier to see, that P is 1, 2, minus 2, and Q is 0, 4, minus 5. And therefore the modulus of P is the square root of 1 squared plus 2 squared plus 3 squared, plus 2 squared, which is 3, and the modulus of Q is 0 squared plus 4 squared plus 5 squared, which is root 41. Then we're asked to find Q minus P. So if I do Q minus P, 0 take away 1 is minus 1, 4 take away 2 is 2, and minus 5 take away minus 2 is minus 3. And then we also need the modulus of Q minus P. So that's 1 squared plus 2 squared plus 3 squared. And that is root 14. Then it's asked us to use the cosine rule, so we need to draw a triangle. So I'll call this vector here P and this vector Q, and notice that I've placed them tail to tail. So this angle theta is the angle between them. And this angle in this direction is Q take away P. Okay, using the cosine rule, the length of Q minus P squared is the other two sides squared minus twice mod P mod Q cos theta. You may want to pause the video for a minute just to check that that is the correct application of the cosine rule for this triangle. Okay, using the figures that I've worked out before, Q minus P is root 14, so square that and I get 14. Size of P was 3, so 3 squared is 9. The size of Q was root 41, so square that and I get 41. Take away 2 times 3 times root 41 cos theta. So cos theta is 9 and 41 is 50, so it's 50 take away 14 over 6 root 41. That comes out to be 0.9370, and therefore theta must be 20.4 degrees. Okay, that gives you an idea of how this works. Now let's generalize. I've got two vectors A and B, and I've called the components of A, A1, A2 and A3, and the components of B, B1, B2, B3. And then I've got a vector C, which is B minus A, as given. So these three vectors form a triangle, which is going to look very similar to the one that I had before. I've got A along here and B there, tail to tail, so this angle theta is the angle between them, and this angle here, B minus A, sorry, this side here is B minus A as before. Okay. Right, so let's have a look at the size of these vectors. Well, the size of C, all squared, so I don't need to bother with the square root signs, B1 minus A1 all squared, plus B2 minus A2 all squared, plus B3 minus A3 all squared. I'm going to multiply out each bracket. And then I'm going to collect things together. So A1 squared, A2 squared, and A3 squared. That's what I've got here. And then B1 squared, B2 squared, and B3 squared is there. And minus 2A1B1 minus 2A2B2 minus 2A3B3 is there. Okay, the first bit is the size of A squared. The second bit is the size of B squared. And the third bit is, well, it's just this expression again. Okay, we've just shown that result. From the cosine rule for this triangle, we've also got this result. And if we compare the two, we can see that mod A mod B cos theta must be equal to A1 B1 plus A2 B2 plus A3 B3. This is a really useful and important result. Because mod B and the calculation on the right are easy to find, we have a method for finding theta. So we get to the scalar product. The scalar product A dot B of two vectors A and B is defined to be the value of mod A mod B cos theta, where theta is the angle between them. And we've just shown that this is the same as A1 times B1 plus A2 times B2 plus A3 times B3. These two definitions are equivalent. So we can calculate the scalar product in a very simple way. It's just 2 times 8 plus 2 times 0 plus 1 times 4. That's 16 plus 0 plus 4, which is 20. Easy. Okay, you have a quick go at one. Pause the video while you work this one out. Okay, just multiply the top pair. Minus 1 times 2 is minus 2, and then the middle pair, 2 times 1 is 2, and the bottom pair, minus 3 times 0 is 0, and that comes out to be 0, which was option D. Now, what does this tell you about the vectors? Well, it tells you that the other version of the dot product, mod A, mod B cos theta, is also 0. but we know that mod A is not 0 because we can see that it's not the 0 vector, and we can see that B is not the 0 vector, so its magnitude is not 0 either. So we must have cos theta equals 0, and that means that theta is 90 degrees. In other words, the vectors are perpendicular. This is a really useful result, and we'll look at it again in a minute. We can use the scalar product to find the angle between two lines. Here I've got the vector equation of two lines, and these vectors here are the two direction vectors. So that's what I need if I'm looking at the angle between them. So I start off by dotting those two direction vectors. That's 2 times minus 5 is minus 10, plus 3 times 2 is 6, plus minus 1 times minus 1 is 1, and that comes out to be minus 3. I also need the modulus of each vector. So the first one, that's 2 squared plus 3 squared plus 1 squared. That's root 14. And for the second one, minus 5, 2, minus 1. Root 5 squared plus 2 squared plus 1 squared is root 30. So the dot product, minus 3, is equal to mod of the first vector, root 14, mod of the second vector, root 30, cos theta, where theta is the angle between them. So now I can work out cos theta. Cos theta is minus 3 over root 14, root 30, which is minus 0.1464, and therefore theta is 98.4 degrees. However, we were asked to find the acute angle between the lines as opposed to the angle as defined between these two particular vectors. And of course the lines didn't need to be defined with those two vectors, they could have been defined with vectors going the other way round. So the angle that we've got is bigger than 90 degrees, so the acute angle is therefore 180 minus that, which is 81.6 degrees. So you need to be careful to check whether a question asks for the angle between two given vectors or for either the acute or the obtuse angle between two lines where the direction vectors are not uniquely defined. Okay, back to our perpendicular lines. If two lines with direction vectors A and B are perpendicular, the angle between them is 90, and that means that cos theta is 0. That means that A dot B will be 0. Similarly, if A dot B is 0, then A and B are perpendicular. It's important to remember that this works both ways. We can use it to find out about vectors if we know they're perpendicular, or we can use it to show that vectors are perpendicular if we know what those vectors are. This is really important and you need to remember this. Okay, a few examples for you to try. Pause the recording and have a go at this one. Right, let's have a look at it. We've got to find the angle between those two vectors, and personally I always prefer to start by writing them as column vectors. So the scalar product, 5 times minus 2 is minus 10, minus 1 times 3 is minus 3, minus 2 times minus 1 is plus 2. So that comes out to be minus 11. Then find the modulus of each vector. So that's 5 squared plus 1 squared plus 2 squared, which is root 30. And then minus 2, 3 and minus 1, that's root of 2 squared plus 3 squared plus 1 squared, which is root 14. Now you'll see these numbers keep coming up, root 30, root 14 we've had before. All that means is that the people working out the questions have stuck to small integer values for the vectors, and that means there's only so many combinations they can have, and the same numbers do have a tendency to keep turning up. Okay, the dot product is minus 11, and that's equal to root 30, root 14 cos theta. And that means that cos theta is minus 11 over root 30 root 14. That's minus 0.5367, and that means that theta is equal to 122.46 degrees. And we're asked to give it to the nearest degree, and that's option C. Note that in this case we weren't asked for the acute angle, but we were asked for the angle between the vectors, so we give whatever angle comes out. Okay, pause the video and have a go at this one. Right, we're asked which of the following vectors are perpendicular to that vector A. So what we need to do is to work out A dot B, and then A dot C, and then A dot D, and see what we get. So A is 4, 3, minus 1, and we're going to dot that with B, which is 1, minus 1, minus 1, and that's 4 minus 3 plus 1, which is 2. So those are not perpendicular. For A dot C, 4, 3, minus 1, and C is minus 2, 3, 1, and we dot that and it comes out to be minus 8 plus 9 minus 1, which is 0. And then A dot D, 4, 3, minus 1, dot that with minus 1, 0, minus 4, and that's minus 4 plus 0 plus 4, which is also 0. So A is perpendicular to C and D, and that's option C. Okay, one more for you to try. So pause the video again and have a go at this one. Do make sure that you've got your vectors the right way round. We're asked for the vectors BA and BC. So if you didn't make sure that you had yours that way round, you might want to pause the video and have another go at this. Right, let's do this then. So BA, not AB, I'm going from B to A. That's minus 1 to 2 is 3, and from 4 to minus 3 is minus 1. The vector BC, that's going from B to C. Minus 1 to 2 is 3, and 4 to minus 1 is minus 5. Then I need the size of these vectors. So root 3 squared plus 1 squared is root 10. And the size of BC, root 3 squared plus 5 squared, is root 34. And then I'll dot them. 3 minus 1 dot 3 minus 5. That's 9 plus 5, which is 14. And therefore 14 is equal to root 10, root 34 cos theta, which means that cos theta is 14 over root 10 root 34, which is 0.7593, and therefore theta is 40.6 degrees, which is option A. Okay, the other thing that you need to be able to do is to find the shortest distance between a point and a line. And the important fact you need to know for this is that that shortest distance will always be perpendicular. So we need the perpendicular distance, and that means we have to find a point P such that the line AP is perpendicular to the line that we were given. The easiest way to deal with this is to look at an example. I've got 3 points which are the vertices of a triangle. The first thing I'm asked to do is to find the vector equation for the line joining AB. So first of all, I'll write down the vector AB. From A to B, that's 3, 3, 6. The equation of the line is R equals, I'll use the vector to get me onto the line at point A, 2, 0, minus 3, and then lambda, my direction vector, 3, 3, 6. Now 3, 3, 6 is clearly a multiple of 1, 1, 2, so actually it's probably going to be easier to work with this line because that'll keep the numbers smaller and the arithmetic simpler. Okay, I'm going to define, so for part B, it says find the shortest distance from C to AB and hence find the area of the triangle. There's a bit of a hint there, hence find the area of the triangle, I need a perpendicular height, and of course the shortest distance from C to AB is indeed the perpendicular height of my triangle. So I'm going to define the point P to be the foot of the perpendicular from C to AB. Then the vector CP is a vector to get me from C to the origin plus a vector to get me from the origin to P. So from C to the origin I've got to go backwards, so that's minus 3, minus 1, minus 2. P is a point on the line, so I just need to get onto the line, 2, 0, minus 3, and then to move along the line an unknown distance lambda in the direction 1, 1, 2. I'm going to write this now as a single vector. So looking at the x components, minus 3 plus 2 plus lambda, that's minus 1 plus lambda. The y component is minus 1 plus lambda as well. And the z component, minus 2 minus 3 is minus 5 plus 2 lambda. Make sure that your lambdas don't look like your 2's. Now then, CP is perpendicular to AB. And that means that if I dot CP with my direction vector 1, 1, 2, I should get 0. So if I actually do that dot product, 1 times minus 1 plus lambda is minus 1 plus lambda, and the same again for the y, and then 2 lots of minus 5 plus 2 lambda, so minus 10 plus 4 lambda. That must equal 0, and that means that 6 lambda equals 12, and therefore that lambda is 2. So therefore, I'm running out of space here. I'm going to use this space here. CP is the vector minus 1 plus 2, which is 1, minus 1 plus 2, which is 1, minus 5 plus 4, which is minus 1. To find the area of the triangle, I then need the modulus of CP, which is root 1 squared plus 1 squared plus 1 squared, which is root 3. and the modulus of AB, and I need to make sure I'm back using the full base of the triangle AB and not my simpler direction vector. So that's 3 squared plus 3 squared plus 6 squared. 36 and 9 is 54, so that's root 54. And the area of my triangle is therefore a half times root 54 times root 3. I can simplify that. It comes out to be 9 root 2 over 2. Okay, now you need to do some consolidation work. Don't skimp on this. You need plenty of practice in solving problems as well as being confident with the basic ideas. And you need to make sure that you do this before you start the vectors topic in Further Pure. I hope you found this set of videos useful and wish you every success in your continued mathematical studies. Goodbye.